Hey everybody, Mr. Carr again. Today we're going to be looking at 6.3 day 2. So after we've learned how to set up our trig ratios, we're going to we're going to be able to use those trig ratios for finding missing sides, and that's our goal today. Quick recall, sine, cosine, tangent. Sine is opposite side divided by the hypotenuse. Cosine is adjacent side divided by hypotenuse. And tangent is opposite divided by adjacent. You should probably do a quick check in your calculator real quick. Look for the button that says cosine, hit that and type in 82. So when you do that and hit enter, cosine 82 should come out to a 0.1392. Okay, this is just to make sure you're in the right setting because your calculator mode needs to be in degrees, not radians. Oops. Okay, so that's just a thing that you'll have to do for that one, just to make sure you're in the right setup for this problem or for these problems here. So our first two examples, it's all about finding missing side lengths. Every time you do these problems, the number one thing I always suggest to do is to first label all your sides based on the reference angle. So 31 is my reference angle, just like we did before. You label your hypotenuse first, and then you go from here. This is the opposite, and that leaves my x value to be the adjacent side. For 31 degrees, we see that there. The next step is take a look at what you know and what you're looking for. I know the opposite side, and I'm looking for adjacent. So I go back and look at my ratios. Which one uses opposite and adjacent? And that's tangent. So notice that as the tangent of theta. Theta is your angle here. Okay. Probably should do that. Theta is always going to be the angle. That's just a reference there. Okay. So tangent of theta is opposite over adjacent. So that means in this scenario, I'm going to do tangent. The tangent of 31 is equal to opposite over adjacent. Tangent 31 is going to calculate a number. You plug this in your calculator, you get a value. It's very similar to like what you would do here. So in this case, what I'm going to do is I'm just going to put that over 1. And now I can cross multiply because it's basically, we're saying that it's almost like a proportion. Okay. So the tangent of 31 over 1 equals 17 over x. I cross multiply. So x times the tangent of 31 is equal to 17 times 1. Here I can divide both sides by the tangent of 31. This right here, this is what's going to go in the calculator. So you're going to type in 17 divided by the tangent 31. So when you do that, x comes out to about 28.29. And that's it. So when I do this one, it's the same exact idea. We're going to set this up twice. So again, label your sides. I go from the right angle. That is going to be my hypotenuse. From the 57, this is opposite. And then this one's adjacent. I'm looking for two different values. So that means I need to do this. I need to do one of them using my known 14. And I'll do this one. So I know the opposite side. I'm looking for hypotenuse in this case. That's going to be sine. So that's the idea. So I'd write it like that. The other one is opposite and adjacent again. So my second one is going to be a TOA scenario. So if I set up both of those, I'm going to take the sine of 57 is equal to opposite 14 divided by b. And the tangent of 57 is equal to opposite over adjacent a. It's the same exact kind of problem as last time. We're going to go ahead and cross multiply here. So I have b times the sine of 57 is equal to 14. Divide by sine 57 to both sides. So when I plug that in my calculator, so again, this is what goes in the calculator, 14 divided by the sine 57. That comes out to about 16.69. Over here, I cross multiply these. I have a times the tangent 57 equals 14, and then I divide by tangent 57 to both sides. So a comes out to about 9.09 when I put that in my calculator. Okay. Quick word problem kind of scenario. This is a common one we like to see in our trig problems. We talk about stuff about angle of elevation and angle of depression. Okay. So it's always going to be measured from a horizontal line. Okay. So when I look at this, so this is a good diagram to help demonstrate angle of elevation, angle of depression. Notice that the person on the ground is looking up at the hot air balloon. That's an angle of elevation now because this person is looking up. So it's elevating there. If somebody's in the hot air balloon and is looking down, that's the angle of depression at that point. So depression means you're looking down. Again, they're both to horizontal lines. Now, because they're both horizontal lines, that makes these parallel lines. So that means angle of elevation and angle of depression are always the same value, as long as you're kind of labeling your diagram correctly. So this person looking up at 38 degrees is the same as this person looking down at 38 degrees. So we can use that on a problem like this. You're at the top of a roller coaster, 100 feet above the ground. The angle of depression is 44 degrees. So that's this one right here. How far do you ride down the hill? So we're looking for this value here. Now, the angle of the idea is the angle of depression for the roller coaster here is the same as the angle of elevation from somebody who's at the bottom looking up. So if you want to put it inside a triangle like that, this 100 I can rewrite over here. So now I have a right triangle that looks like this. We've got 100, we've got 44, and this is the side I'm looking for. Now do the same exact things we did before. We're going to label our sides. We have H from the 44 degrees here. That's going to be O. And then this is adjacent. So I'm using O and H. So I'm going to use sine. The sine of 44 is equal to the opposite 100 divided by my hypotenuse X. So just like the previous problems now, we are going to go ahead and put that over 1 and cross multiply. So X times the sine of 44 equals 100. And divide both sides by the sine of 44. Okay, so it says about how far. It does not say what we want to round it off to. So I'm just going to say X is about 143.96 feet, or about 144, I guess. Okay. There is one more style of these problems. I want to do a quick, it's not that one. I'm going to do, I think you try now number 2 real fast. Yeah, I'm going to do this one. So we're going to draw this out real quick. You are 50 feet from the screen at a drive-in movie. So if I look at it like this right here, here's the screen. You are 50 feet away. This is not a very good drawing, but this is 58 degrees to look up. Your angle of elevation to the top of the screen is 58 degrees. How tall is the screen? So we're going to call that H. So from here, I guess I shouldn't do it. Let's call it A for altitude. So from here again, we're going to do, this is my hypotenuse, this is the opposite side, and then this is adjacent side. In this case, we're going to use tangent again. It's O and A. So we're going to use tangent of that. So if I take the tangent of 58, that is equal to opposite divided by adjacent. Now notice on this problem, we have, well, I should say, we have a little bit different setup. Every problem before had my variable on the bottom, 100 over X, 14 over A, 14 over B, and 17 over X. This is just a little bit different. And it's not that bad, but we just got to be careful how we put it in the calculator. When I do my cross multiplications now, I have A is equal to 50 times the tangent of 58. I highly, highly suggest you put the number in front of your trig. Okay, it's very easy to make the mistake if you try to put it afterwards, that it gets calculated a little bit weird. But if you always put it in the front, so you do 50 multiplied by the tangent of 58 degrees, that will give you a more accurate, that'll give you that there's less mistakes that can happen there. So when I do that, I get A to be about 80.02 feet for the height, or about 80 feet when you look at your key at the bottom. Okay, so that's it. Just make sure if you ever have to multiply with your trig, put the number in front. If you are dividing with the trig, it doesn't really matter. Just put that in your calculator the correct way. All right, but that is it for today. So again, we're using trig ratios to find our missing side lengths. Just make sure you are always setting up and asking the questions, which side do I know, if it's opposite, adjacent, hypotenuse, and then which side I'm looking for. That helps you decide which trig ratio to set up, and then you just do cross multiplication. All right, that's it for today. Take care, everyone.